Hey everyone, in this video we will understand about how we can implement look this scheduling algorithm using the C and C++ program. So in the last video we have already discussed about the implementation of the scan this scheduling algorithm in the C and C++ program. So the prerequisite to understand this current video, that is the implementation of the look this scheduling algorithm, is you should understand that how we can implement this scan algorithm. So you must watch the video of the scan algorithm implementation in the C and C++ program. Why? Because in this video, I will just tell you the changes that are done in the look this scheduling algorithm implementation. Okay, because you can say 98% of the code will be similar to the scan algorithm. Okay, for our look algorithm. Okay, so I'll just tell you the changes that I have done for the look algorithm. Okay, rest of the things you can just go through the video of the scan algorithm. Okay, so it is better that you first watch the video of the scan algorithm. Okay, then it will be very easy to understand this look algorithm. Okay, so do watch them. So now let's start with our look this scheduling algorithm implementation in the C and C++ program. So in the previous video we have discussed about the look this scheduling algorithm and how we can apply this on an example. So we were given the request queue, right? And the initial position of the read write head is 53. Okay, so in this example our read write head is moving in the lower cylinder number to the highest cylinder number direction, right? In this direction. So according to that, if we apply the look algorithm, then we have to start from the 53, right? And then we will go, okay, till the last request in the request queue, that is 183. And you know then in look algorithm, we do not go to the end cylinders, right? So in this question, the hard disk has 200 cylinders total, right? That is from 0 to 199. So in the scan algorithm, as we have seen in our previous video, we will go from the current position of the read write head to the last cylinder number also, that is you can say end cylinder number. Okay, although the request, that is the last request, is 183, okay, in this request queue, but we go to the end cylinder also, that is 199 here. Okay, but in the look algorithm we do not go to the end cylinder. Okay, so this is the optimization that is done in the look algorithm. So we'll go to the last request, that is 183, and after that we'll reverse the direction of the read write head. Okay, and then we'll go in this direction and we will serve the request, right? So this is the small change in the look algorithm with respect to your scan algorithm, right? So if we go in this direction, then we found that these are the total head movement, okay, and these were the average head movement, okay, in the look algorithm, right? And now let's say if we are moving in this direction, that is highest cylinder number to the lower cylinder number. Okay, so in scan we saw that we will go from 53, that is current position of the read write head, okay, then to 14, okay, because 14 is present here. Then we will also go to the this end cylinder, that is 0, okay, in scan algorithm, right? And then we will change our direction, right? And then we will go to this 183, okay. But in look algorithm we saw that we will go from 53 to only 14. After that we will reverse the direction, we will not go to this 0. Okay, in look algorithm we will not go to this 0, right? And after 14 we will reverse our direction and we will fulfill the other request, other pending request. Okay, the last request is 183, so we will stop here. Okay, so only this change. Okay, here we are going till 0, but here we are not going till 0. Okay, so this is the small change that is in the look algorithm. Okay, and then we found the total head movement and the average head movement. Okay, so here it was 236 cylinders traversed, here it is 208 cylinders. Okay, obviously it will be lesser because we are not like going from 14 to 0 and 0 to 14 in look algorithm, right? So this small change that we are talking about, this will be coded in your implementation of your look algorithm. Okay, that is we do not need these end cylinders. Okay, the hard disk contains cylinders from 0 to 199, right? But in our program we will not be needing this 0, okay, and this 199, right? We will just be needing the you can say the last request. Okay, in this direction last request is 14. Okay, so we'll just go to the 14, right? But in the scan algorithm, as we are going to like 0 in this direction, so we need to code this 0 also in the scan algorithm, right? So I will tell you what do I mean by this coding of this 0 and this 199 in our program. Okay, so before this, let me show you the output of the look this scheduling algorithm by running my code. Okay, so here is basically our C++ program for the look this scheduling algorithm, and this is the C program. Okay, so let me run the code. Okay, the output of the both C and C++ program will be same. Okay, so let me run the C++ code. So first the program is asking total number of cylinders. Okay, so I entered, we have total 200 cylinders, that is the hard disk size is 200. Okay, now I have to enter the number of cylinders that we want to enter in the request queue. So let's say I want to enter 8 cylinders in the request queue. Now I have to enter the actual cylinders. So for our example, it was like 98, 183. Okay, this was our, like you can say, the cylinders in our request queue. Okay, so I'll enter all the cylinders. Okay, so after I entered the cylinders in the request queue, now I have to enter the initial position of the read write head. Okay, so I will say currently my read write head is, let's say, at 53 at position. Okay, I'm taking the same example that we have just seen. Okay, now we have to enter the direction also in the look algorithm, as we have entered the direction in the scan algorithm, right? So let's enter the direction. So I have assumed that if we are moving from lower cylinder number to the highest cylinder number, okay, that is from 0 to 199 direction, then I will enter direction as 0. Otherwise, if we are moving from 199 to the 0th direction or the 0th cylinder, okay, that is in the left direction we are moving, then I will enter 1 as the direction. Okay, so let's say we enter 0. Okay, we are moving in the right direction. Okay, so here is the output. Okay, so this is basically seek sequence. Okay, this is basically the seek sequence that I have printed. Okay, you can just print seek sequence. Okay, the wording. Okay, so this is the seek sequence, that is the order in which your cylinders are traversed. Okay, so first I traverse 53, then I traverse 65, then 67. Okay, slowly I come to 183. Okay, and you can see after 183 we are going to the 37 and 14. That is, after 183 we are just reversing the direction. But if you just go back to the scan algorithm, in that, if for the same input, we will see that from 53 we are going to 199 also. Like after 183 we will go to the 199 also, and after that we are changing the direction, then we are going to 37 and 14. Okay, so this is the small change also in the look algorithm. Okay, 199 will not be present here in the output of the look algorithm. Okay, but if 199 is present in my request queue, then there is like no other way, we have to go to the 199. Okay, what if 199 or the last cylinder, or you can say the end cylinder, is not present in the request queue, then we need not to go. Okay, and these are the total number of head movements, right? And this is average head movement. Okay, the same way you can take the direction as 1, and you can get the you can say the seek sequence, average head movements, and the total number of head movements also. Or you can take the other examples also. Okay, you will find the link of this code in the video description below. Okay, now let's go to the implementation and understand how the code of this look algorithm will look like. So this is our code for the look disk scheduling algorithm. Okay, this is the C++ code. Okay, the C code is also similar, right? So basically, as I told you, that the code of the look algorithm is basically similar to the scan algorithm. So what is the change? So basically, if you go to the scan algorithm, okay, the C++ implementation, here this was the code, okay, that we have written. If direction is 0, then we were doing this thing. If direction is 1, then we were pushing this thing, right? So basically, after that, this was the code, right? This total was the code. Okay, okay, for the scan algorithm. Now, if we check for the look algorithm, basically this, if direction equal to 0 and if direction equal to 1, this code will be changed. Here you can see. In the look algorithm, we are just saying if direction is 0, okay, just enter the initial cylinder number or the current cylinder number that is given to you in the question by the user, push in the right. Otherwise, if direction is 1, you are moving in the left direction, push the initial position of the current cylinder number in the left. Okay, in the scan algorithm, we were saying if direction is 0, push two things: the initial position, current position, and the last cylinder numbers or the end cylinders also. So if we are moving in the right direction, then enter, let's say we have the total cylinders as 200, to 200 minus 1, 199 also. And if direction is 1, that is we are moving in the left direction, then push 0 also along with the initial position. But in the look algorithm, we are saying we will not enter these. Okay, this 199, okay, and this, you can say this 0 if we are moving in the left direction. We will just push the initial positions in both the cases. Okay, so here you can see only this change is there. Otherwise, all the code, okay, all the remaining code, it will be same, okay, exactly same as per the scan algorithm. There is no change. Okay, You can just compare by also yourself. Okay, you can just download the code and you can see I have not made any change. Okay, all the rest of the code is actually similar to the scan algorithm. Okay, so let's understand what does this code mean. Okay, that is why this code will work. Okay, if we do not enter the last cylinders. Okay, we have also understood that we need not to enter the last cylinders. Okay, but how this code will actually work. Okay, let's understand. Okay, and then this is only thing that I have to make you understand. Okay, so let's see. So basically we saw in the scan algorithm implementation that the basic idea was that we have to sort our request queue. Okay, we have to sort our request queue. So this was the idea. So if we sort our this request queue, right, so this we will get 14 to 183. Okay, after sorting this. Now if let's say we are saying we are applying the look algorithm on this example, then let's say initial position is given in our question as 122. Okay, and let's say user say my direction is 1, that is I'm moving in the right direction. Okay, so from 122 I'm moving in the right direction. So in scan algorithm we saw that we will go to till 14 and after that we will go till 0 also. Okay, to the end cylinder also. But in look algorithm what will happen? After 14 we will just change our direction. We will not go to this part, right? So 122 till 14 and after that we'll change our direction and we'll go till 183. So basically we saw that in scan algorithm we were saying that why we were sorting the request queue, because we were coming to the idea that let's say this 122 is the current position. So we were saying okay, as you are going from 122 to this 14, right, so you can just scan this array. Okay, the sorted array from 122 to 14 and you can just subtract okay them. Okay, and you can find the total head movement. Okay, and the same way from you can say in scan algorithm we saw okay after 14 you have to go to 0 also. So we were like appending 0, right, in the you can say left part or the left array. Okay, or you can say left part. Okay, and we will go to 0 also, and after that from 0 to 124 183 we can compute using the this part. This was you can say this was the right part. Okay, so if we just sort this array then there is no concept of as such left or right. Okay, but to make this thing simpler we were explicitly taking the left and right array in our example, or you can say in our look algorithm. Okay, so basically if we talk about this example, okay, so we are moving in this direction. Let's say current position is 53. Okay, so we were taking two extra arrays, okay, other than our request queue, left and right. Left will store all the cylinders which are lesser than our initial position of the read write head. Okay, that is all the cylinders which are lesser than 53, they will be stored in this, and all the cylinders which are greater than 53, they will be stored in this right. Okay, and we are taking these cylinders from the request queue. Okay, so basically what will happen if we talk about the scan algorithm? Okay, this is for the scan algorithm. So we will go to from 53 to 199 also, right, although 183 was the last request, right? Then after that we will change our direction. But in look algorithm what will happen? We'll go from 53 okay till 183. 183 is the maximum request in this direction, and after that we will change our direction. We will not go to this part, right? Okay, so basically in the left array, okay, in the left array what will be the content and what is the content in the right array? So basically as I told you, this was the first thing that we have to do. We have to insert something here, okay, in the left and in the right, in the right array. So in the scan algorithm we were saying, let's say we are moving in this direction, that is if our direction is 0. Okay, if direction is 0 we are moving in the left direction, sorry, in the right direction. Okay, in the right direction. Then we were saying we need this 199 also in the right. Okay, so we were appending this 199. Okay, and then we were appending this current position also, this 53, right? So this was the code. If direction is 0 we were pushing the total cylinder -1. If total cylinder is 200 we were pushing 199 and the 53, right? But in look algorithm, as we do not need this 199, okay, so we will not execute or we will not write this line. We will not push this total cylinder -1, that is 199, that is this part. Okay, so this line will not be present in the look algorithm. We will directly push this, or you can say insert initial position or the current position that is given in our question 53. Okay, here. Okay, So for this example, we will just insert 53, right? So after this code gets over, then we will run the remaining code. Okay, after remaining code, what will happen? So after this code, the next code that is present in our code, what it will do, it will actually insert all the cylinders which are actually lesser than 53 in the left array. Okay, so what are the you can say cylinders which are present here and they are lesser than 53? You can say 14 and 37. 14 and 37 will be scanned from this array and they will be put here. So first 37, then 14. So 37 and 14. So again, you can see this is same as the, you can say, scan algorithm. Okay, we will scan this and then we will put it. Okay, now again, what are the cylinders which are greater than 53? You can see all these cylinders, right? 65 to 183. So all these cylinders are put here. Okay, so this thing is exactly same like the scan algorithm, right? Okay, so yeah, there is no change after that. Okay, after that the code will be working on this left array and the right array as we were working in the scan algorithm. Okay, again after that there will be no change. Okay, so if we talk about this question, okay, this question, if we are moving in this direction, then what will happen? We need not to put this 0, right? That is, if direction is 1, okay, we are moving in this left direction, then we just need to put again the initial position, that is 122, okay, in your left array or the left vector. Okay, we will not put this 0, right? And after that we will just push what, all the lesser values, that is 98, 67 till 14, okay, in our left array, and in the right array we will push 124, 183, again same as the scan algorithm. Okay, the main thing is if direction is 1, we will not push this 0, right? So here you can see if direction is 1, we are just pushing initial position, we are not pushing this 0. Okay, this line is again not present in the look algorithm, so only this change is there. Okay, we are not pushing 199 and the 0. Okay, now if we talk about this corner case that we have seen in the scan algorithm also, that is, if you can say this is the minimum cylinder that is given in the request queue and this is the maximum cylinder that is given in our request queue. Okay, if the user enter the initial position of the read write head which are lesser than this 14, okay, let's say this is 2, so 2 is the initial position of the read write head, then in the look algorithm what will happen, will go from 2, okay, to 14, then all the requests will be traversed, okay, and we'll stop at 183, right? In the scan algorithm we will also stop at 183 because after that there is no other pending request. In look algorithm also we will stop here only, right? Okay, so in the same way we can say, let's say if our initial position is 184, okay, then we will start from 184 till 14. Okay, so these are the corner cases in which we are just you can say going only in one direction, we are not reversing our direction. Okay, here you can see after 183 there is no pending request, we are not reversing our direction, so in one go our all the requests are completed. So in that case also our this code will work. Here you can see if direction is 0, okay, we are saying in look algorithm just push 53. Okay, so here you can see if our direction is 0, we are pushing just the initial position, so that is we are pushing the 2, okay, in the right array. Okay, we are pushing this 2, okay, we are not pushing this 199. Okay, in scan algorithm also, as I told you, we were not pushing this 199. Okay, so if direction is 1, then we can see we have to just push 53, right? So in scan algorithm also we were not executing this line, we were not executing this line, okay, if our this case is present, and for saving this case, okay, that we will not execute this line. Okay, this line will be like executed on the basis of some condition. Okay, so here you can see in scan algorithm, okay, this is the code of the scan algorithm, we were executing this line based on some condition. Okay, if our corner case is present, then we will actually not execute this total cylinder -1. Okay, this line will be false. Okay, so for protecting this line we were writing this thing. Okay, you can go back to the scan algorithm, you can better understand that why we were putting this line. Okay, so this was saving the corner cases. Okay, and in the same way if direction is 1, okay, we will not push this 0. Okay, so this was the line that was saving this, that is we will not push 0 and 199. Okay, and in look algorithm, okay, as we are removing these lines all together. So we need not to write this if conditions. Okay. So here you can see in look algorithm, we are just saying push the initial position, right? So our, you can say, corner cases is also handled in the look algorithm by just writing these lines. Okay, there is no other than other if else. We need not to find the minimum element, maximum element. Okay. So this is very much, you can say, simpler than the scan algorithm, right? So in this question here you can see what we are saying, that after you have the left and the right array, we were doing the sorting, right? Sorting on the left and right. So if we do the sorting, okay, this will not be present. After doing the sorting, this will be the content in the right array. Okay, and in this case left array will be like empty, so there is nothing. Okay, so after that this everything is similar. Okay, just the main thing is whether the end cylinders will be present in the, you can say, right and the left array or not. After that we have to just go through the same code as we were seeing in the scan algorithm. Okay, so that means if we are given the initial position at 53, okay, we will just go to the 183, and after that we will reverse our direction, okay, till this. Okay, so yeah, this is the same code that we have seen in the scan algorithm, right? We were first going from 53 to 65, then till 183. Okay, so this 53 to 183 cylinders, they will actually be present in the right array. Okay, so we will just do calculation for 53 to 183 only. Okay, so this loop will only run for 53 to, you can say, 183 only. Okay, 199 is not present. Okay, so it will work as such. Okay, after that our direction will be changed, and then again we will go here. Okay, and then we will say, okay, we have to run this again. Why? Because if you have seen in this scan video, you are saying completed initially was 2. We have to run this code 2 times. So now after 2 it is 1. Okay, and we'll go again. We'll say now my direction is not 0, my direction is now 1. So now I will come here, and in this code, okay, we will actually execute the left array. So in the left array my 37 and 14 will be present. Okay, 37 and 14 will be present. So I will do that calculation. Okay, so as left array will only have but 14 and 37. Okay, so this code will work from there only. Okay, so basically initially my initial position, okay, that was changed to 183 in the, you can say, this part. Okay, so I'll first do 183 minus, you can say, 14. Okay, or you can say not 14. Basically I'll start from here, right? You can see left size minus 1. I'll start from here. Okay, so my sorted array is 1437. Okay, this is 0th position, this is 1st position, but I'm starting from backward, as you can see here. Okay, we have to simulate this thing only. We have to subtract 37 from 183. So 183 minus not 14. Okay, 37. 183 minus 37. So accordingly we will do the calculation in the total head movement. Okay, and then plus next time what will happen, my this 37, okay, this will become the initial position, right? Initial position. Okay, and then I'll go here, and then I'll say, okay, 37 minus next element, that is 14. 37 minus 14. Okay, whatever answer will come, I will append here, or I can say I will add here. Okay, and then after that it will be over. Okay, and then after that my while loop will be like wrong. Okay, and then I'll come out. Okay, so total head movement will tell me the total cylinders traversed, and in both the cases I am just appending the cylinders in the seek sequence. Okay, same as the scan algorithm. Okay, so this is also same, exactly same as the scan algorithm, right? So in the same way you can run this code also. Okay, this code means this example also, you can see that this will work similar to the scan algorithm. Okay, so basically this is actually apply look algorithm, right? In our look algorithm, okay, everything is same. So before ending the video, you can see again, okay, this is the code, then this was the code. Okay, so this was just pushing the initial position. This was saying, okay, lesser element will be going to the left and greater cylinder will be going to the right array. After that we sorted both the left and the right vectors or the right arrays. Okay, after that we run this code. Okay, again same code. Okay, and the main code is asking the same thing that we have seen in the scan algorithm. Okay, so I hope you have understood that what is the change in the look algorithm with respect to the scan this scheduling algorithm. Okay, so yeah, this was all about this video. So I hope you have understood the change and you have like this video. So please like and share this video, and if you forget to subscribe this channel, please subscribe the channel and press the bell icon for further notification of the videos. See you in the next video with our other algorithm implementations. Till then, goodbye.